We are live. Or I am. Excuse me. How do whatever. That's interesting. So, one viewer. Okay. I am not doing anything right now because I am waiting to, okay. All right, 2 people. So here's how this is going to go. There's a Q&A app. You should be able to submit questions, and I should be paying attention most of the time to whether there are questions. And I'll just be doing stuff, hopefully somewhat interactively, so yes, do feel free to ask questions. So, pencilcode.net is a website that's made specifically for basically teaching JavaScript to anybody at all, or coffeescript to be more precise. since it's a flavor of JavaScript basically. So you can either hit the Let's Play button, or you should probably log in if you want to save stuff. By the way, I'm not expecting anybody to follow along at all. This is just a viewing for fun thing. Yeah, so when I log in, I get all of my thingies that I've already had, and I can start, and no, that's not what I wanted to do. I can start a new file, and I'll call it GameTest. You can see that by default it starts in block mode, so you can drag out blocks that are like right 90, where is it, forward 100, but first I want to put down a pen. Let's say the pen is red. And so it does stuff. So the turtle is the main thing you're controlling normally in pencil code. But I can also just tell the blocks to go away since I know the type of code I want to type in, and just type in code. So suppose that I want to move to, at the bottom there, I'm looking at my coordinates. And then left 90. And then left. Yes. Let's see how that turned out. So I messed something up. Oh, I put an equal sign there. But it says, yeah, unexpected equal sign, because it wasn't expecting me to do that. So yeah, that's the basics of, I actually meant to do -100. That's why the equal sign was there. Those are the basics of pencil code. So yeah, there's a turtle. You can tell it to do stuff, and that's what a lot of kids will do a lot when they're playing, just playing around with it. So if I save it and then I can either say open window, so I can open my whole thing in a new window, and you can see that there is no more grid. The grid is just part of the IDE, the integrated development environment. So this is real JavaScript, a real HTML page that does a real thing. So we'll leave this for now, actually, because we'll need it later. But I'll start with a new file. It'll be a physics game. So I've got this turtle, and I can make it move around and such. And I will set speed to infinity because I will need it for the interactive bits. Don't worry too much about why speed infinity, but the turtle moving around slowly at finite speed is not compatible with basically any sort of interactive thing you want to do. Because its speed is independent of like logic, computer logic speed. So yes, speed infinity is good for games. And then we will immediately make a forever loop. I think this is the syntax for a forever loop. We could go into blocks, and yeah, that's what a forever loop is supposed to look like. You can put in a timer here. So yeah, at equally spaced times. But the default is fine by me, so I don't have to say 1, comma something. I'll just say forever. And I have to tell it forever what? Forever. And we will move. And now it moves forward over and over and over again a tiny bit. Oh, okay, that's cool. We will make a velocity variable, and the velocity will be 0 and 0 to start with. There are two numbers in velocity because there is how fast you're moving left to right, and there is how fast you're moving up and down. So if I say, instead of just move by 5, I can say slide. Actually, I think move is the preferred method. Slide is deprecated. We can say move velocity. This is probably not going to work. No, this does not work. Actually, we don't know whether it works because we made velocity very small. Oh, it does work. Hey, cool. All right. So, yeah, it moves by 1 to the right and 1 up forever. So it moves very slowly that way. If I made it like this, it's now moving slightly faster, but still pretty slow. This is very fast. Okay, so let's start with 0, and let's add some physics finally. Physics, gravity. I think that this is all measured in pixels per undefined time frame, so they're just numbers. But I think 0.5 is a good idea. If not, we can change it. So actually, yeah, let's do this. So now, well, velocity 1, so this is velocity 0, this is velocity 1, as you may remember from your data structures related learnings. We will add gravity to it. Now what will happen? So this is the horizontal, this is the vertical. Velocity 1 is always the vertical, and velocity 0 is always the horizontal. There's probably a better way of naming it, but oh no, we're falling, but we seem to be falling up. That's easy to fix. Let's make gravity negative. So up is positive, down is negative in this particular system. In fact, you can see it, I think you can see it. Yeah, in the very bottom right corner, you can see when I move the mouse around the screen, it tells me what the coordinates are. So if you experiment and down makes the number more negative, up makes the number more positive. Now we're falling off the screen. Great. So maybe we don't want to fall off the screen. If not, yay, now it's bouncing. What did I just do? Okay, so the turtle is the name of this particular turtle that just comes for free with your beginner program. You can actually turn it off if it doesn't make sense for you to have one single main turtle. You can turn it off, and then you can make new turtles and say t dot forward or something. But so turtle refers to this turtle. Dot touches. The dot is a standard way of referring to things that an object can do. So a turtle has a touches function that checks whether it's touching something. And window is a special object. And I'm putting parentheses around this because this is maybe what you're more used to. In CoffeeScript, parameters to a function don't have to go in parentheses. They just sort of go space separated after that function and comma separated. And it's sometimes easier to read, sometimes harder to read. So, but yeah, in English, it makes a lot of sense. If the turtle does not touch the window, then we reverse the velocity. And velocity 1 equals negative velocity 1 says, oh, wait, we were falling with great speed, and now we should be going up with great speed. And because gravity acts on the velocity, that's the physicsy part that I sort of skipped. Because gravity acts on the velocity, it accelerates the turtle every step. You may notice that for some reason, the turtle is jumping higher every time. I can't tell you why that is. And it went bye-bye. This is probably due to A, rounding errors, although I'm not sure why it would round differently. Or B, we really shouldn't be, reversing it like that at the bottom, because we might want to make it a lot slower at the bottom when it reverses. So then let's say we reverse it, and then we make it smaller. So if right here the speed was like, and I'm saying velocity and not speed just because speed is already a keyword. It was like 100, and we're going, and we've decided to reverse. Then instead of it reversing to going 100 up, it'll now go 90 up. So it'll slow down a little bit at the bottom. So that's nice. Now it actually goes a little lower every jump, which is a good thing to have. What else was I going to do with this? Oh, that's right. So suppose that we also make it move sideways. And let's say we make it have a green pen, so now it's drawing stuff. Yay! Now we can see parabolas. And maybe scoot it over a bit. Nope. I confused X and Y. There we go. So just by saying every frame change your speed by the gravity, we get all of this cool parabola-like behavior sort of for free, because we're accelerating the turtle toward the Earth every frame. And, it starts up over here when it's just bounced. It starts up going really fast, up. And then because we're subtracting a little bit from its speed, eventually the speed becomes 0 right here. And then the speed starts going down. Any questions yet? No questions yet. Okay. And that's basic gravity. I am cheating, by the way, a little bit here, because I know that if the turtle is not touching the window, that's probably because it went off the bottom, and we probably want to reverse the speed up. So otherwise, I can't really say that whenever you need to bounce off of anything, you should just start going up instead of going down, or vice versa. That doesn't make a whole lot of sense, especially if we start running into diagonal obstacles or horizontal obstacles or anything else. But I mean vertical ones and stuff like that. But right now, this works perfectly fine. So I mentioned that I'm going to come back to this one. That's because I want to now take all of this. Oh yes, this also has visual debugging, so you can tell that like when it did the move to, that's where it moved, and when it did the right turn, that's where it turned. It's pretty cool. So I'll take all of this, and I'll move it here. And I'll actually, no, I won't. So because speed is now infinity, this should happen really fast. Oh, hey, look at that. What happened? Well, one thing that happened is that we've been turning around. So when the turtle drew this thing, at the end of this drawing right here, the turtle is facing sideways. So then when I told it to just go somewhere else, it was still facing sideways. And then when I told it to be falling, it's apparently falling toward its own bottom. That's the way we wrote this, not so much toward the bottom of the screen. Why is that? Well, that's because when I say move by the velocity, it basically taking a relative vector. It's treating the velocity as a vector that is relative to the turtle. So if I wonder if I can just do this. Is it going to complain if I do this? Yes, it is. Okay, fine. If I take this all off, if I take the forever loop out, and the turtle is stuck right here right now, right? When I told it inside the loop to move by this velocity, which at this point is 2, 0, I'm telling it to move by 2 that way, right? To its own right. Don't mind the text right now, because the text is just telling you how you might get over there, over to where my mouse is pointing. Now, when the velocity starts jumping in, then it says, well, okay, you move by 2, and then you also move by what? By the gravity. And then next time you move this way. So when I say that gravity is negative 0.5, that means that every frame we're going to be moving more toward the butt of the turtle. So the bottom of the gravity is always the butt of the turtle. So maybe that's not the best thing. Maybe we wanted to move in absolute positions, but if we, as long as we don't rotate the turtle, or we put it back before we start doing stuff like that to it. So and we can see that if we want to face up, we want to left turn 90, which is useful. And I'll put the pen back up because I don't want to know all this. Okay, cool. Now we did the same exact thing, except that we've reset it back to where it's supposed to be, and it's doing the right jumpy thing. Now, I'll move it up a little bit, and I will change when we bounce. We will now bounce if the turtle does touch red. Ooh. Ooh. Pretty crazy. It did a little weird thing there. This is completely unrehearsed, by the way, in case you were wondering. It did a little weird thing there because it just bumped into the edge and it just didn't know what to do with that. So suppose that we don't, so this, I'm just going to start commenting my code. Suppose that instead of my computer's being slow. Instead of moving to here, we move just a little bit back so it doesn't hit the thing as bad. That's a little nicer. So notice that when it doesn't do like weird things with the hitting, with the ziggy-zag thing, The way that the friction, if you will, let's call it friction of collision, although that's completely physically not correct, but that's okay, diminishes this top point in a pretty nice straight line still, regardless of where it hit the bottom. This is, I think it makes some sense if you think about it. The idea is that if we didn't have any friction and we didn't have any kind of like weird I made a mistake. If we didn't have the weird thing that sent us higher every time, which is probably, I don't know, rounding error. I'm going to go with rounding error. The answer is always rounding error. Then we would go in a straight line. So whatever, this would basically be a perfect mirror around this line. We would say, well, we were going down with this speed, and now we've hit the ground, and now we're just going to go up with the same exact speed. And we're still moving sideways constantly, so that's that. When we go up with the same exact speed, we will hit the same exact height, theoretically. So, and every time, if we do get lose some speed every time we hit, and it's a constant amount of speed, then this makes a nice, pretty line. Okay, that's fun. Now, we probably wanted to make this a game, so what we probably want is to be able to control the turtle with arrow keys. So inside the forever loop, because the forever loop is where everything happens, we can also say if, as I Google it, or look it up, pressed, as in a button is pressed, and the button that I want is D, because I'm going to, well, let's say A. I'm going to control it with WASD, I think. If pressed A, what will we do if A is pressed? We will, let's just try doing, you know, the really simple thing. We'll just move by left is negative and 0. So -5 means horizontally we want to move in the negative direction. 0 means vertically we don't want to move if A is pressed. Let's try it. So here it is, I'm not pressing anything. I got rid of the, I made velocity 0, 0 to start with, so it doesn't have, hey look, I'm moving. Okay, that worked nicely. Oh. Huh. Okay, copy paste. Great. Now, D increases my thingy and A decreases it. If I were making a really like physics-based platformer, I would probably mess with velocity instead of directly affecting where it goes. Oh god, I broke it. It fell. So if I were making a good, nice, polished physics-based platformer, probably instead of just saying, suddenly move the turtle, I would tell it, change your velocity by a little bit to the left or right so that you would be going left or right, faster or slower. And I would probably put a lot of air friction on it. And air friction would just be the same thing I did right here, the same exact thing, but for both up and down and left and right. And I might even do, it being a game and not the real world, I might do different amounts for up and down air friction versus left and right air friction. It would be a lot bigger. It would be like 0.99. And then once all that is done, I could say just keep moving left. In fact, why don't we try that? So yeah, let's say the velocity is 0, 0. So instead of moving, let's say when the button is pressed, then velocity 0. Actually, I probably want to make it smaller when I'm pressing A. So what happens then? Oh, wrong buttons. Ooh, it's all smoother and less jaggedy. Except that I haven't put in air friction yet. So now, once I start pressing A, it's going to the right forever. And once I start pressing B, it's going to the left forever. And got confused. Yeah. So clearly our algorithm is not quite working on the vertical lines. Because, as I said, the bouncing only makes sense for the horizontal lines. So now we can also say, regardless of what buttons may or may not be pressed, we'll we will add some air friction. Oh, wrong button again. So now I press right, but it gets very quickly, it stops. So I'm holding it down all the way. It's probably a lot easier to play around with when you're actually the one playing around with it. So I don't quite like 0.9, so I'll probably do 0.99. And it does, as you can see, if I let go of the button, it does start going vertically right away. So, and here yep, we're very confused. And it doesn't quite zero out as much. So yeah, that's the problem with making a real physics-based platformer is the sort of the bottom line, sort of. When it's going really slow, but still sort of squinting over to the side, and then you have to tell it, if you're going that slow, then please just stop, that sort of thing. So because I don't want to mess around with it that much, I'll just change it back to the non-physicsy derpy way. And I'll get rid of air friction for now too. Air friction is a pretty good idea anyway in physics games. Whoa, whoa. Okay. Now, in a platformer, we don't generally bounce around all the time until we run out of velocity. Generally, we also have a button that lets us jump. How do we jump? Well, jumping does make a lot of sense to do velocity-wise because, as you can see, bouncing and velocity are great. So vertically, so velocity 1, let's say 5. Why not? I broke something. Oh, this is not Python. Okay. I'm pressing the button. It's not doing anything. Well, okay. Now it's doing something. 5 may be too much. 2. And the other thing we'll do, what about if the touches, then we don't quite bounce, or better yet, we bounce a tiny, tiny bit. There you go. Ah, what happened? Ah, I know what happened. So, you may have noticed that I can press and hold the button, and look at that. Press and hold A and B, and just keep moving left and right. So what I've done is actually I've given him more of a rocket pack than a jump, because if I press and hold W, it keeps increasing his velocity as if he has a little propeller or rocket pack that just keeps propelling him. So that's probably not what we want to do. There is another way of doing buttons that does not go inside the forever loop, because forever is, you don't always necessarily, unless you're making specifically a game, you don't always necessarily want to say forever do this. So the other type of button, in fact, we can actually cheat and look in the blocks and say, there's my button. I want to put it here. Button. Oh wait, no, sorry. The button will put an actual physical button on the screen. What I want is key down. So this is a function that says, whenever you press W, I want something to happen. And what do I want to happen? Well, this thing. Where are they? Oh, nope, I don't like that at all. I'm just gonna stop doing the blocks. The backticks are an artifact of putting an empty key down thingy. So right now this is a compiling error because there's nothing inside that if. The backticks make it so there is something inside that if and doesn't do anything. 1, 2. Now, there's something wrong here. I am using velocity before I've defined it. Okay, now what? Okay, so I believe that the reason 5 was too big is because I was holding the button down. Yay. Now I have a platformer, a very basic platformer. So the difference between the key down event is that it's a single event, right? When the W key gets hit, a thing happens once, versus if I'm inside a forever loop and I'm saying, is the W key pressed down right now? If so, please add a little boost. That's a little bit more boosty than we want for our jump. Maybe you want to make a game with a rocket pack. You may notice that I now have infinite jump. I have double jump, triple jump, as many jumps as I want. This is probably not, whoa, I broke it, good. So it is, it does automatically decide that when you're holding a button, it's the same as if you're mashing it. So there are ways around it, but I don't care enough because we're about to fix it in a different way. So what do we want to do? We want to say, if you are in the air, don't let us jump more than like once or twice. So zero. That's the number of jumps we have done so far while being in the air. So when the key is down and we boost the velocity a bit, we will add 1 to the number of jumps. And when we are touching the ground, which is red, we will reset the number of jumps. Hopefully this works. Because now we've touched the ground and we can do a double jump again. I broke it. There is no plus plus. Now this doesn't actually do anything yet because I didn't tell it what to do with the number of jumps. Although we could print it out. There's a right. Yeah. So right just writes it again and again. Okay. And then when we touch the ground, it'll start over again. So we only want to be able to jump if the number is less than 3. For those of you who have experienced Python, this may look familiar. I broke it. The indentation-wise, because you don't put things in braces. So only the indentation defines what's inside. In fact, the braces are bad, and it'll complain at you. So now I've got a basic platformer. Now what? How many jumps do I have? Oh, that's because I'm in here. 2, 3, 3. So yes, I can do triple jump. Yay! What happened right there? Well, we jumped. You can see that we were sort of, somehow we got into the ground. You can also see the turtle bouncing a tiny bit. So there are issues with physics. There's always fiddly issues with physics and with platformers. So I could say, if you're touching the red, then please move away from the red so that you're not actually stuck in the middle of it, because we were going so fast, we basically got stuck in the middle of the red. And so that when you try to jump out of it, you don't like, aren't still stuck in it. I can't reproduce it now. But yeah, there's always bugs to fix. In general, though, it's working pretty well. We can turn off the green line. The green line is just there to show us how it's working. Yep, there it went again. I guess when I jump off the platform, or maybe when I double jump off the platform. Oh, here I am. So here I am, stuck in the middle a little bit. And I guess that it does actually make me go up a tiny bit. So experiment, figure things out. Okay, we'll stop writing number of jumps because now it's scrolling our window. Change numbers to correspond to different things so that your platformer doesn't quite break as easily, because as you can see, I can jump much higher than my one and only platform. So what happens here? Well, surprisingly, nothing super terribly bad. So I was expecting it to freak out a little bit because, you know, we are now touching red. I should be reversing my velocity. That is what it's doing. So it's crawling up very slowly because it's reversing its velocity back and forth and multiplying it by stuff. And so that's making it just crawl up ever so slowly. And this is sort of, I think, the artifact you notice here a little bit, because you can see it goes down a bit and then keeps crawling up because we're telling it, reverse your velocity, you're touching ground. But you're still touching ground, still reverse it, and so on. So strange things are happening. We could take care of it in a real way and say, well, don't actually reverse your velocity, figure out where the solid thing is and don't go through the solid thing, or, you know, reverse it in a way that bounces off the surface regardless of where it is. But all that sounds very hard, and I don't like it. So what we're going to do is use the visual debugger and find these. Okay, so this forward 50 makes this platform. So we will make the pen blue for that platform and then red right afterwards. And same with this forward 50. Oh, and I forgot, but I can tell. Oh, it's blue. Oh, first of all, oh, wrong key. It's not going to be crawling up anymore because it's not touching red, it's touching blue. And blue, it decides is like, not important. It's all right to be touching blue. I'll just go through it. And now, maybe we'll say, if you are touching blue, So that's the problem when you're mixing the velocity-based movement with move-based movement. So what we really want to say is, if the turtle is touching blue, prevent movement. So if we were only ever using velocity for movement, we could have just said clamp down the velocity to 0 and maybe scoot us back a little bit so we're not touching blue anymore. But we can't say that because we're not using velocity to move because we're cheaters. That's okay. We will just cheat some more. We will say oh yeah, let's see. Let's put it this way. And not still going to be problematic. You'll see why. You may already understand why. What are you talking about? Okay. In that case. Sometimes it gives you weird errors about things that aren't even in your code because, as I mentioned, CoffeeScript is a language that's compiled to JavaScript, and these errors are referring to the JavaScript code. Yes. Now there are no more errors. Now what? Oh, now we stop moving when we're touching blue. Except that we're still touching blue, so now it says you're not allowed to move anymore. We're allowed to jump out of it because I didn't say anything about W. But when we ran into a blue wall, we just completely stopped moving. That's probably not a good idea. Now, the really, really cheaty way to do it is to make left walls blue and right walls red or something like that, or green. So I could make this wall green, for example, and then we could say, well, if you run into a green wall, then you're probably going from the left, and so disable moving to the right, and so on. That would be easy when you're doing like compound cheats like this. Eventually you run into really weird logical things, like what if you have a wall that you're not supposed to pass from either side? Of course, then you could make it a double wall. So we could, this is a slightly better idea. If A is pressed, so we're going and we've hit this wall, then, well, let's say we move into the wall, and then we can say, but wait, if you are now, after you've moved, touching something blue, then please undo that. So move back. Oh, and then if D, we're holding down D and we're going, and then we suddenly start touching something blue, and we say, wait a second, we've moved, and we started touching blue, so let's move back a little bit. Let's see how that works. Oh, wrong key again. Oh, that's nice. Yeah, that works. Except for the part where we touched blue with our butt. and stopped moving right there. So that, I think, is best fixed with just good level design and not having a blue jutting out of there. You can see that our height varies quite a bit when we're on the platform. That's okay. As long as we don't fall through. That's why I made him 10. That's why the thickness is 10, so that we don't go straight through the platform. Whee! We even bounced a little bit when we were jumping high. Oh, that's nice. There you go. There's your basic platformer in, what, 40 minutes? Questions? And we'll turn off. Again? What do you mean? How did this happen? Oh. I know how this happened. I was trying to play the game, but instead I was typing things. Now we've got a turtle jumping around, being a platformer. And so, yeah, in most, again, physics-based platformers, even in Mario, really, if you look, they made things a lot more elaborately. And when I stop holding the left or right button, I don't immediately start stop moving left or right. It's much more smooth, and it's more of a velocity-based thing, but they control it in slightly different ways. Now, what else? I could make like a canon game on top of the platformer, but that'd be boring. Nope. So I think I'm going to cut this short because, one, I'm done with what I wanted to show, and two, there is one person here anyway. Thank you again, one person. If you go to this URL, which I'll actually also paste in my showcase. If you go to that URL, which is where I was just now, you will be able to edit this exact code, and you will not be able to save over it in my account, but you'll be able to log out, log in, or make a new account and save your version when you like it. So, yeah. Good luck, have fun. Maybe somebody will watch this in recording. See ya.